Let's go to page 433, and this is lesson 7.1. This lesson is to apply the Pythagorean theorem. It says one of the most famous theorems in mathematics is the Pythagorean theorem, named for the ancient Greek mathematician Pythagoras around 500 BC. This theorem can be used to find information about the length of the sides of a right triangle. Okay, so remember this applies to right triangle. So when you have right triangle, okay, the side that is next to the right angle is called a leg. So you have one leg here, one leg here. The side that's facing the right angle is called a hypotenuse. Okay, so here's a theorem. So theorem 7.1, Pythagorean theorem. So this is a super important theorem. Make sure you need to know it, okay, by heart. It says in a right triangle, the square of the length of the hypotenuse is equal to sum of the square of the length of the legs. So when you have a right triangle, okay, so you got a square, so square of the leg plus the square of the leg equal to square of the hypotenuse. Okay, so if you notice, okay, when you have a right triangle, so in this case, if you notice that so you have the Pythagorean thing is a squared plus b squared equal to c squared. Okay, again, if you notice what's a squared, well, a squared means, imagine if you have a square, if you draw the square like this, so this is a, so a squared is the area of this side, b squared would be like this. And c squared would be, in this case, is so if you notice by looking at the picture, the Pythagorean theorem says a squared plus b squared equal to c squared. If you just look at it from geometry perspective, notice it's the area of this side plus the area from this side equal to area of this side. Okay, and notice there are similar figures, right? Now, one interesting about this is that this is true not only for the, so basically you have the k of one side plus k is the area, because I don't want to use letter a, because letter a is used for angle, used for a lot of stuff. Okay, so I'm going to call this area 1, area 2, area 3. Okay, so the area of this shape plus area of this shape equal to area of this shape. Okay, now this is true not only for square, but as long as they are similar shapes, okay, then this would be true. Okay, so for example, you can even have like equilateral triangles. Okay, so if you have like an equilateral triangle, okay, they have to be similar shape. They have to be the same shape. So again, this area of this triangle plus area of this triangle equal area of this triangle. Okay, and also again, as long as they are similar shape, then this would be true. Okay, so if you can even have like semicircles. Okay, so if you can have a semicircle, so the area of this semicircle plus area of this semicircle equal to area of this semicircle. Okay. So again, that's kind of interesting thing about Pythagorean theorem. Okay. Okay, now let's go to example 1. Okay, finding the length of a hypotenuse. Okay, so again, first, if you notice, it's a right triangle. So again, in order for this to be true, you have to have a right triangle. Okay, so when you have a right triangle, then it would be the square of one leg plus square of the second leg equal to square of the hypotenuse. Right? See up here? So hypotenuse square equal to leg square plus leg square. So you got x square equal to 6 square plus 8 square. Then just work it out. Okay, so 6 squared is 36, 8 squared is 64, and when you add, you get 100, you take the square root, you get 10. Okay? Now, because normally when you take the square root, you get plus or minus 10, but because this is a physical object you can have a negative 10 length, right? Length of negative 10. So that's why you only take the positive square root. Okay? Okay. So let's go to example 2. So it says a 16-foot ladder rests against the side of the house. So you got 16-foot ladder linked against a house, and the base of the ladder is 4 feet away. So you see this is so the base of the ladder is 4 feet away from the house. Approximately how high above the ground is the top of the ladder? So again, the building and the ground it forms a right angle. Therefore, this is a right triangle. Therefore, you're going to have an a squared plus b squared equal to c squared. Okay, so that's your length of square, right? That's a hypotenuse. The length of the ladder square equal to distance from the house. That's your a square, and the square of the height of the ladder. That's your x squared. Okay, so you can so you apply that. So you're going to get 16 squared equal to 4 squared plus x squared. And you multiply out, 16 squared is 256, 4 squared is 16, okay? Minus 16 on both sides, you get 240 equal to x squared. And then from there, you're just going to use your calculator, take the square root, you get about 15.491, okay? Okay, and here is the proof, okay? And we're not going to go through that proof. You can look on your own, okay? Okay, so example 3. Okay, example 3 says find the area of an isosceles triangle. Okay, find the area of an isosceles triangle with a side length of 10. So side length of 10, 13, and 13. So you got 10, 13, and 13. So whenever you have isosceles triangles, put the one that's different on the bottom, and you just go and cut in half. That way you get 2 congruent right triangles. Okay, so again you got 10, 13, 13. So the one that's different, make that the base, and make the 2 same length as the side. So that way when you cut that, it will give you a nice 2 congruent triangles. Okay? Okay, so again the 10, when you cut in half like that, you get 5 and 5, right? So now to find out the height, or to find the area, you find the height first, right? So height, again you apply the Pythagorean theorem. Okay? So you got c squared, okay, equal to the 5 squared plus the h squared, right? A squared plus b squared equal to c squared. Then you substitute, so 13 squared is 169, 5 squared is 25, minus 25 on each side, you get 144 equal to h squared. Then take the square root, you got h equal to 12. Okay? So once you find h equal to 12, to find the area, again, try to use letter k for area, because again, a, especially when you get to trigonometry, a lot of time a is used for its angle A, so you don't want to get confused. So it's better to use K, the capital letter K, for the area. Okay, so triangle is the area of a triangle is 1/2 base times height. So 1/2 times the base is 10 times the height is 12, and it will give you 60 meters square. Okay. Okay. Now next, here's the most important concept that you need to really know by heart. The common Pythagorean triples and some of their multiples. Okay, so notice you got 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, right? Okay, so let's go over that. Okay, so let's look at you have a 3, 4, 5. Okay, okay, and then you have the 5, 12, 13, and you got 8, 15, 17, you got 7, 24, 25. Okay? Now, as you do these, okay, there are some interesting things that you need to know. Okay, obviously, Pythagorean theorem, you got 3 squared plus 4 squared equal to 5 squared, right? Okay, so that's something that, okay, I'm going to do these. Okay. And same thing, so again, Pythagorean theorem, you got 5 squared plus 12 squared equal to 13 squared. Okay? You got 8 squared plus 15 squared equal to 17 squared. You got 7 squared plus 24 squared equal to 25 squared. So that's your Pythagorean theorem. Okay? Now, another interesting fact you can see from the relationship is that if you notice, okay, I'm going to fold this over. A Pythagorean theorem, you also notice that 3 squared equal to 4 plus 5. Okay? And if you notice this one, 5 squared equal to 12 plus 13. Okay, so if you square the smaller side, it will equal the sum of the two longer side. So this one, okay, the even is kind of very different. Okay, we're going to talk about the evens later. Okay, so this one, so only talk about the odds. Okay, for the odds, 7 squared equal to 24 plus 25. The evens have different pattern. Okay, so by this conclusion, we can see that if it's a 9, okay, what would be the other two numbers to form the triple? Okay, well, if you go 9 squared, will equal to 9 squared is 81, so it would be equal to 40 plus 41. By the way, see that consecutive numbers, right? See 4, 5, 12, 13, right? So 24, 25, and 24. So this would be 9, 40, 41. Okay? And if you continue, what happens if you have 11 squared? 11. Okay, what would be the other two numbers? Well, 11, so 11 squared equal to 121. So the other two numbers would be 60, 61. Okay, so the pattern can continue. Okay, so again, that's an interesting fact about that. Okay. Also, another thing that you can learn about this is that, like if it's, so we're going to look at the patterns. Okay, so if one of the number is odd, okay, if it's for the odd number, then what you do is you square the number, square, and then you divide by 2, okay, and you go on either side, okay. So the 2, then get the nearest integers. Okay, so for our number, you square, then you divide by 2, and you go to the either side. So for example, 3, so if you have a 3, right, you square, become 9, and you divide by 2, you get 4.5, and you get the two nearest integers. Okay, so two nearest integers would be 4 and 5, right? Okay, because 4.5, so see that, so 3, you get 4 and 5. Okay, now if you try 5, okay, if you square, you get 25, divide by 2, you get 12.5. Okay, to the two nearest integer would be 12 and 13. See, 5, 12, and 13. See that? So again, there's a lot of interest. That's why math is very interesting. There's a lot of interesting patterns and interesting fact. Okay. Okay. Now 7. Okay. If you square, you get 49. Divide by 2, you get 24.5. And the two nearest integer, you get 24, 25. That's where you get 7, 24, 25. See that? Okay. And the pattern continue, right? Now what happens if it's even? Okay, if it's even, then you have to do the opposite. So if it's even, you divide by 2, and then you square. Okay, and you get the two nearest integer, or closest. Okay. Okay, so for example, if you have 8, so you divide by 2, you get 4. You square, you get 16. And you get two nearest one, you get 15 and 17. Okay, so you got 8, 15, 17. See that? Okay. So if you try like 4, if you start with the lowest number, right? So 4, okay, you divide by 2, you become 2. You square that, you get 4, and you get the two nearest one, you get 3 and 5. And that's you get, see this one, you get 4, 3, 5, right? See that? Okay. And what happens if you start with 6? Okay. For 6, you divide by 2, you get 3. You square, you get 9. And two nearest integer would be 8 and 10. Okay? So you got 6, 8, 10. Okay? And this is what we're going to talk about next, is that this is like your basic, this is like your primary, this is called a Pythagorean triple. Okay? So this is your primary Pythagorean triple. And so any multiple of that, okay, is also good. So like if you multiply that by 2, you get 6, 8, 10. If you multiply by 3, you get 9, 12, 15. If you multiply by 4, you get 12, 16, 20. Okay? If you multiply by 10, you get 30, 40, 50. So basically, this is going to have ratio of 3x, 4x, 5x. Okay? Now, same thing with this. You can have any multiple of that. Okay? So if you have multiplied by 2, you get 10, 24, 26. If you multiply by 3, so everything's all based on your primary triples. Okay? And you get 15, 36, 39. If you multiply by 10, you get 50, 120, and 130. So they have a ratio of 5x, 12x, and 13x, and so forth. So this will have ratio of any multiple of like 8x, 15x, and 17x, and so forth and so forth. Okay? Now, why is this important? Well, if you know the pattern, okay, a lot of problems that you have to solve would be super easy. It will save you a lot of time. You don't have to go through the lengthy Pythagorean theorem using a squared plus b squared equal to c squared. Okay, if you know the pattern and know the triple, sometimes you can just look at the problem and you can get the answer right away, instead of having to go through the lengthy Pythagorean theorem, especially numbers get really big. Okay. Okay. So let's go to example 4 to know what I'm talking about. Okay. So on page 436, example 4. Okay, so you have this right triangle, and you have 10, 24x, right? So the normal way, if you don't know the triples, okay, then the normal way is you have to use Pythagorean theorem. So you're going to get 10 squared plus 24 squared equal to x squared. Okay. Now some people like to put x squared in the front. Doesn't matter. You can have a squared plus b squared equal to c squared, or you can have c squared equal to a squared plus b squared. Okay, it doesn't matter. I kind of like do it this way. I like to kind of arrange from the smallest to the biggest. Okay, but you can do it either way. So you're going to get 100 plus. Okay, now you have to see. It's kind of hard to do it without a calculator, right? So I go 24 squared. Okay, equal to 576 equal to x squared. Then you have to add, so you get 676 equal to x squared. So this one you have to use calculator, right? Without calculator, it's kind of hard to do. So you have to take the square root of 676 and push equal, and you get, so x will equal to 26. Okay? So you have to kind of do this, and you have to use calculator. Now I'm going to show you how to do it without the calculator. So to do this is, what you do is arrange this from the shorter side to the longer side. Okay, if you don't know which is the longer side, doesn't matter. The hypotenuse is always the longest. So you're going to go 10, 24, and x. Okay. Then what you do is go and factor out as much as you can. So these are divisible by 2. So divide by 2, you get 5, 12, and this one you don't know, just call it, use a different variable, y. Okay. Now, if you recognize your triple, see it's 5, 12, 13, right? See that? So you know that. So from this has to be equal to 13, okay? And now you go backward, okay? So you factor out the 2 to get 13. So this has to equal to 26, okay? And that's how you can do it very quick, okay? And you can do it without calculator. Okay. So let's go to the guided practice for example 4. So for guided practice number 7, okay, you have this triangle, and you got 9, 12, and x, right? Okay, so you go 9, 12x, right? See, you can factor out the 3, so divide by 3, you get 3, 4y, okay? And from here, again, this is your 3, 4, 5, right? So y equal to 5, and therefore x will equal to 15, right? Because there are 3 over here. So that's it, so x equal to 15, okay? So that's why it's so important to know your triplet and know the pattern, okay? So especially, you're going to see probably this 3, okay? This one probably not so much, but you're going to see this one a lot. This is most, and this one is quite a bit, and this one also, okay? So make sure you recognize especially these 3, and realize once you know the basic, the primary triples and any multiple of that, okay? So basically when we do this, we try to factor out to get to the primary triple. And once we get the primary triple, we can go back to the original numbers. Okay. Now, not every problem can be done that way. So when you try, if you don't get it, but it still kind of helps. So if you go to the guided practice, okay, on page 436. Okay, so this is guided practice. So you have this triangle. So you got x, you got 48, and you got 14, right? So now numbers get big. Again, if you don't have a calculator, this is what you do. You go 14, 48, x, okay? I'm going to use blue. Sometimes red is kind of hard to see. Okay, so go and factor out the 2. You get 7, 24, okay, and y, right? Now, if you notice, again, 7, 24, so y equal to 25, and so x will equal to 50, okay? And so, and label, this is centimeter, centimeter. So answer would be 50 centimeters. So again, if you know the technique, it can be done very quick, okay? But if you don't know your technique, you have to do it a long way. You have to go x squared equal to 14 squared plus 48 squared. So you got x squared equal to, now you have to use calculator, okay? So again, when you do this, you don't need a calculator, and you do it very quick, okay? So 14 squared, okay, you get 196, and now you have to do the 48 squared. Okay, so you got 2,304, okay, then you have to solve, okay? So you got 2,500, and you take the square root, and you get 50. Okay, so again, this is a normal, regular Pythagorean theorem, and this is just kind of the shortcut technique. So you can see this is much quicker, and you don't need a calculator. So make sure you know, but for that, you kind of have to know your triples, yeah?